Good morning, students. Today in the last lecture we have studied the electric dipole. Now we will study the electric field at different positions of the dipole. On that day I have told you that means that we will be discussing three positions. One is the axial position, one is the equatorial position, and if a point lies here or if a test charge is placed here, it will be general position. We are going to find the electric field at axial position. We are going to find the electric field due to dipole at equatorial position, and we are going to find the value of electric field due to dipole at general position. So first topic is, according to our syllabus, electric field at a point on axial line due to dipole. That means now we will place a test charge or any charge at a point on the axial line and we will calculate the electric field due to this dipole. Suppose M is a point where charge is being placed, test charge is being placed, and we will calculate the distance of this M from the center of dipole. M is a point on axial line at a distance R from the center of dipole. That means from dipole, not from center of dipole. Dipole is 2L length, L here, L here, L on this side, L on this side, 2L length minus Q. And you know that the effectiveness of electric dipole is calculated by dipole moment, and the direction of dipole moment is minus Q2 plus Q. So we are calculating the distance from center. So you know that this is also a charge and this is also a charge. This will also apply electric field on this point, and this charge will also apply electric field on this point. The electric charge from positive Q is radial outward in this direction, and the electric field due to minus Q is radial inward in this direction. This is electric field due to plus Q, it will be in this direction, and the electric field due to minus Q will be in this direction. As positive Q is near to M, minus Q is far away from M, so it will be strongest because inversely it depends on the distance. This electric field will be strongest. We will subtract weakest from strongest. So from plus Q, M is at this distance. So what is the distance of M from plus Q charge? From center it is R. From R you have to subtract L. You will get the distance as R minus L. From plus Q charge, the M point is R minus L distance at. And from minus Q, what is the distance of point M? Here R is there, plus L plus R. And you know that the electric field due to a point charge is 1 upon 4 pi epsilon naught charge upon distance square. So the formula of electric field due to a point charge is 1 upon 4 pi epsilon naught charge upon distance square. So plus Q is also applying the electric field and minus Q is also applying the electric field. So electric field due to plus Q will be 1 upon 4 pi epsilon naught. What is the value of charge in plus Q? Plus Q. Or Q, magnitude is Q. Upon distance square. What is the distance of M from plus Q? R minus L square. So like this. So the electric field due to minus Q, 1 upon 4 pi epsilon naught, charge is Q, magnitude you have to take the magnitude, and what is the distance of minus Q? R plus L. So you have to take here as R plus L square. You know the direction of electric field due to positive charge is in this direction, and direction of electric field due to negative charge is in this direction. Sorry, like this. So we will take this direction as positive and we will take this direction as negative, as both are acting in the different directions. So we will take this electric field as positive electric field and we will take this electric field as minus electric field. So you know that positive is strongest and negative is weakest. Its distance is less, its distance is more. So we will subtract electric field due to positive charge from electric field due to negative charge. We will get the net electric field. This you have to do the subtraction. You will put E plus Q here, E minus Q here, then you will do the subtraction. So same way here is explained the same way. Electric field due to plus Q, electric field due to minus Q. Then we are making a difference from plus Q to minus Q. 1.4 pi epsilon naught 1.4, it will become common. It will come outside. Q lies here, Q lies here, Q will also come common. What remains in the bracket? 1 upon R minus L square minus 1 upon R plus L square. Then you have to perform the mathematics concept. This will go this side, this will go this side, they all will multiply with each other. So when you open this, when you open this, all these things will cut off. Only what will remain? 4 pi RL will remain. And at the downside what will remain? R square minus L square ki whole square remains. So what is this? You just convert this concept into what you have got. You have got like this. Net electric field we have reached to this. We will take from this. Net E 1/4 pi epsilon naught into Q to 4 RL R square minus L square whole square. So we will make some changes here. What changes we are going to make? So you just change this thing. 1 into Q into, make it as 2 into 2L R. Okay. And what is this? Q into 2L. This is dipole moment. 4 pi epsilon naught R square minus L square ki whole square. What is this? This is dipole moment. So net E is going to change. Net E is equals to 2 into dipole moment into R. 2 into dipole moment into R upon 4 pi epsilon naught R square minus L square ki whole square. So we have got net E. I am writing again 2 P R 4 pi epsilon naught R square minus L square. You know that R is very long and L is very small. R is very longer than L. Neglect L. Only R will remain in the relation. 2PR 4 pi epsilon naught. We have neglected this L. So only what remain? R square upon square. So 2PR 4 pi epsilon naught R square square R की power 4. Cut 1 R with R. What will remain? 2p upon 4 pi epsilon naught R cube will remain. So this is the net electric field due to a dipole on the axial position. So this is in simple form. If we want to express this thing in vector form, E is a vector quantity. 1 upon 4 pi epsilon naught 2 into P is a vector quantity upon R cube. So this we have written the relation in vector form. E is depending on inversely upon R cube in case of dipole. But when we have studied the same E in case of point charge, it is inversely proportional to distance squared. So this is the difference. In case of dipole, it is means related to R as R cube, and in the point charge, it is related to R as R square. So you know that this is a dipole, minus Q plus Q, here it is M on the axial position. The electric field due to plus Q is strongest and due to minus Q is weakest. So the net direction of electric field towards the strongest one, E plus Q, that means the this net E is going to have same direction as the direction held by E plus Q. That is means outward, radial outward. It will be outward. Direction of net E will be outward. How it is outward? In this direction. And what is this direction called? Dipole moment. Minus Q2 plus Q, what direction? Dipole moment. So the direction of net E will be along dipole moment. Net E direction will be along dipole moment. So this is we have means given the direction concept also, and we have given the relation concept also. So this is the concept in case of dipole. So we have got the net E relation in, like we have changed this for RL 2 into 2QL into R. 2QL is dipole moment, 2PR upon 1. L is very small as compared to R. We will neglect the L. So what will mean? 2PR upon 4 pi epsilon R4. We will cut E at axial point, net E at axial point 1 upon 4 pi epsilon 2 pi upon R cube. So this is the vector form. Point charge depend square, dipole depend cube. So the direction of electric field is along a dipole moment, because the electric field due to plus Q is stronger. So the net will have the same direction as holded by the E plus Q. So this is the concept. So concept, listen, in point charge it is dependent R square, and in Q, in dipole it depend upon R cube. So if it decreases by 3 times, that means 3 3s are 27. So 27 times dipole will get up faster. So we can say that when we are considering the case of dipole, electric field is decreasing at a faster rate as compared to a point charge. If it decreases by 3 times, only 9 times it will get affected. It will get decrease 3 times, 27 times it will get affected. So electric field due to dipole is decreasing at a faster rate in case of dipole as compared to a point charge. So this is also very much important point. So we have found the electric field at axial point due to dipole direction of that. So now we will coming on to the next topic, make it as a next topic, electric field at equatorial position due to electric dipole. So suppose this is dipole. We will be now considering the case of equatorial position. This is a center point. L distance here, L distance here. Now we will consider a point here, suppose M, on equatorial position. So plus Q will also apply electric field on this, okay, in this direction, outward. Minus Q will also apply electric field on minus this M, this charge, but in this direction. Okay, one is applying in this direction, one is applying in this. In which direction resultant will act, we will come on to later at that concept. And the direction of M is, suppose we have taken it as R. This is a 90-degree angle. So this is base, this is perpendicular. What is the value of hypotenuse? R square plus L square. Distance of M from plus Q. Same way, same distance. Under root R square plus L square. We have applied the Pythagoras theorem here. One electric field due to plus Q, electric field due to minus Q. So you know that the electric field due to plus Q, what is the formula? 1 upon 4 pi epsilon naught Q. What is the distance? Distance is, means suppose distance square, no? That means distance is hypotenuse square. And what is the value of hypotenuse square? Hypotenuse square value is R square plus L square. So what is the value of this hypotenuse square? Like this. Here what we have to do, hypotenuse square, because this distance is hypotenuse. Hypotenuse square value is R square plus L square. So its value is 1 upon 4 pi epsilon naught Q upon R square plus L square. So like this. Similarly, due to negative Q charge, the electric field due to minus Q is 1 upon 4 pi epsilon naught q upon r square plus l square. Okay, like this. You know that the electric field due to plus q, here it is plus q, no? It is acting on point M in this direction. We will make its two components like this and this. Suppose it is making theta with this. So which component is this? This is E, na? We will means divide this. This is the resultant of this two, na? So we will divide this E cos theta, and what is this? E sin theta. So these two components are due to E plus Q. E plus Q is having two components. One is E cos theta and one is E sin theta. Similarly, we will consider this minus Q concept. Here it is M, na? So it is acting in this direction. So we will consider two components, one here and one here. Suppose it is making theta with this same theta, it will become E cos theta and it will become E sin theta. So these are the two components that is due to E minus Q. We are doing the vector concept. We are dividing this resultant into two parts. So this E sin theta is in upward direction and this E sin theta is in downward direction. At point M, one E sin theta, it is in upward direction and one E sin theta is in downward direction. So they have different directions, so they will cancel each other, and one concept at M lies at, one is E cos theta due to plus Q and one E cos theta due to minus Q. They both will get added because they are having the same direction. They are having different direction, they will cancel each other. Okay, like this. So net E, what is the value of net E? E cos theta plus E cos theta, 2E cos theta. It will be 2E cos theta. Like this. And you know that the electric field due to plus Q, if we take its magnitude, and electric field due to minus Q, if it's take a magnitude, it is same. It is equal to E, suppose, because it is also having plus Q is also having the same value and minus Q is also having the same value. Direction is different, magnitude is same. So the magnitude of plus Q minus Q is same. Suppose E, we are taking as E. So due to plus Q, this is E cos theta. Due to minus Q, it is E cos theta. E cos theta, 2E cos theta. So you know the value of this E. What is the value of E? 1 upon 4 pi epsilon naught Q upon hypotenuse square. 1 upon 4 pi epsilon naught Q upon R square L square. You will know value this. Net E is equals to 2 into 1 upon 4 pi epsilon naught Q upon R square plus L square. But you don't know the value of this cos theta. You have to find the value of this cos theta. You know, we have got this situation like this, and here the angle is theta. Here you know this line and this line are parallel, na? This line and this base is parallel, na? So if it is theta, what is going to be it? Corresponding angle, it is theta. So this is 90 degree. What is this? This is R. And what is this? This is L. And what is the value of this? R square plus L square under root. And what is the value of cos theta? Base upon hypotenuse. What is base? Base is L. And what is hypotenuse? Under root R square plus L square. What is base? Base is L. Hypotenuse is under root R square plus L square. That means you have got the value of this cos theta, which you are going to put here. So net E 2 into 1 upon 4 pi epsilon naught Q upon R square plus L square. What is the value of here? Cos theta. L upon under root r square plus L square. This is 1 by 2, this is 1, this is 1, and this is 1 by 2. What is the value of 1 plus 1 by 2? This is 3 by 2. You take it as LCM here. 2 plus 1, 3, 3 by 2. So this will become 3 by 2 into 1 upon 4 pi epsilon naught QL upon r square plus L square the power 3 by 2. This is net E. So what this becomes? 2QL. This is dipole moment. So P upon 4 pi epsilon naught r square plus L square power 3 by 2. Same case we will consider. R is very much greater than L. We will neglect L. So what is the value of R here becomes? We will neglect L. That means what will remain here? P upon 4 pi epsilon naught r square power 3 by 2. This 2 will cut with 2. Only 3 will remain. So P 4 pi epsilon naught r cube. So net E value is P upon 4 pi epsilon naught. So we have derived the value of net E in case of equatorial concept. So what is the direction of this so direction is this now, this. So direction is this. This is the direction of net E. We have taken minus Q plus Q, and the direction of electric dipole moment is minus Q2 plus Q. It is opposite to minus Q2 plus Q. Net T direction. So we will say that its direction is opposite to the direction of a dipole moment. Dipole moment is having direction of this minus Q2 plus Q. It's having direction like this. Okay, this is the concept. So are you getting this now? We have derived this net P is equal to 1.4 pi epsilon naught r cube. So this is the concept. So this net E is having a direction opposite to dipole moment, but in case of axial position, it is having the same direction as that of P. So the electric field will be stronger in axial as compared to equatorial. How it is means double. Here it is only P is equal to P upon 4 pi epsilon r cube, and there is 2P. So the electric field on axial is double as compared to equatorial point. It is P, and on that side it is 2P. So this is the concept. So this is all for today. Your homework is to derive the relation of electric field at a point which is placed on the axial position of a dipole, and electric field due to at a point on the equatorial position of a dipole. You have to find these three concepts. Two concepts you have to do. This is your homework. This is all for today. Hope you enjoyed today's lecture. Thank you very much.